Hello, this is Ms. DB, and today we are going to learn how to solve systems of equations algebraically with substitution. This is from Chapter 6, Section 2. Remember that in 6.1 we graphed lines, we graphed linear equations, and we found the place where they intersected. That point where the lines cross is the solution of the system of equations. So in these two problems, we graphed y equals 2x minus 5 and y equals negative 3x plus 15, and we found that the solution, the point where those two would cross, would be at 4, 3. So that point works in either of these equations. Sometimes it's hard to find an exact solution by graphing. It might be a decimal point, or the equations are not set up for graphing. They're not real nice equations. In this case, we can use a method called substitution. So we're going to be solving with algebra. The goal when using substitution is to reduce the system to one equation that has only one variable. And then we can solve the equation by the methods that you learned already on how to solve equations. Here's our steps for solving a system of equations by substitution. Our first step is to solve for one variable in at least one equation, if necessary. Sometimes that step is already done. Then, for step 2, we substitute the resulting expression into the other equation. That's why this is called substitution. For step 3, we solve that equation to get the value of the first variable. In step 4, we'll substitute that value back into one of the original equations and solve to find the value of the other variable. Then all we need to do is write that as an ordered pair, x comma y, and check. Sometimes the last step would be step 6, which would be to check your answer and see if it works in both of your equations. On your worksheet, we have those same steps, but it's written as a flow chart where you start at step 1 and you move your way through, and then here step 6 is added, which is to check your answer. So you can use that on your worksheet to make sure you're following all the steps. Let's look at this example. We have y equals 3x and y equals x minus 2, and we want to solve, which means to find the coordinate that they would have in common, where they would intersect. Our first step is supposed to be to solve one of the equations for a variable, either y equals or x equals. That step is done because actually both of them are solved for y. Step 2 is to take what y is equal to, which is 3x, and to plug it in where we see a y in the second equation. So we take what y is equal to, which is 3x, and we replace it in the second equation. So now instead of y equals x minus 2, we have 3x equals x minus 2. Our third step is just to solve that equation, 3x equals x minus 2, for x. So we have an x on both sides, so we subtract x from both sides so that we get our x's together. And then we have 3x minus 1x is 2x. On the right side, all we're left with is a minus 2, which becomes a negative 2. Then we need to divide both sides by 2 so that we get x by itself. So we divide this side by 2, and over here on the right we have negative 2 divided by 2, which is negative 1. So we have found our value of x. We have found our first variable. Now we take that value of x and we plug it back into one of our original equations, either one, whichever one you think looks easier. They picked y equals 3x. Now we replace the x with negative 1 because that's what we found x was equal to. And 3 times negative 1 is negative 3. Step 5 is to write that as an ordered pair. Negative 1 is the x value, negative 3 is the y value. And step 6, or the second part of step 5, is to check that by plugging our value of negative 1, negative 3 back into both equations and seeing if you get true statements. So if you plug it back into y equals 3x, we get negative 3 equals negative 3. That's true. If we plug it into y equals x minus 2, we get negative 3 equals negative 3, which is true as well. So it checks, it works in both of our equations, so then we know that negative 1, negative 3 is a solution to this system of equations. All right, here's a problem from your worksheet. we are going to solve this system by substitution. We have y equals x plus 1 and 4x plus y equals 6. Our first step is already done. We have our top equation is already solved for y. So we're going to go ahead and start with step 2, which says to take what y is equal to and replace that where we see y in the second equation. So in our second equation now we have 4x plus x plus 1 equals 6. We don't necessarily need these parentheses here. Now step 3 is to solve that equation for x. Oh, they combine their like terms here. So we had 4x plus 1x is 5x, and then there's the plus 1. Now we're going to solve that for x. So we need to subtract 1 from both sides, and that would give us 5x equals 5. Then divide both sides by 5, and we get x equals 1. So we have solved for one of our variables. We got x equals 1. And then our equations again were y equals x plus 1 and 4x plus y equals 6. So after you solve for one of the variables, you're going to plug that back into one of the originals. Which one do you think would be easier to find the value of y? Probably the top one, because y is equal to x plus 1, but we already know that x is 1. So pretty quickly we can find that y is going to be equal to 2 in this. That's what they're going to do in this next part here. They're plugging in our 1 and they get that y is equal to 2. Then step 5 is just to write it as an ordered pair. And then step 6 is to check your answer by plugging it back into your two original equations. So y is 2 is equal to 1 plus 1. Yep, that works. And the other equation was 4x plus y equals 6, so we take 4 times 1, that's 4, plus 2 is 6, yep, 6 equals 6. So it works. Sometimes you have to solve one of the equations for a variable before solving with substitution. If you do, pick the simplest, easiest equation to solve for one of the variables. Like in this example, we don't already have x equals something or y equals something. So now we have to do step 1. You can pick either one of these to solve for x. Either one would be easy to solve for x. Let's solve the top one for x. All we would do is have to subtract 2y from both sides. So now we would get negative 1 minus 2y, or they wrote it as negative 2y minus 1. Either way is fine. So we've done step 1. Step 2 now is to say, well, now that we know what x is equal to, we will put that in our second equation where we see an x. So our second equation becomes negative 2y minus 1 minus y equals 5. Now this is the same as negative 2y minus 1 minus 1y, and we need to combine our like terms. So we would simplify this to negative 3y minus 1 equals 5. Now step 3 is to solve that and find what y is equal to. So we would add 1 to both sides and get negative 3y equals 6, and then divide both sides by negative 3, and we will get y equals negative 2. So now we know what y is equal to. We still need to figure out what x is. So pick the easiest equation to find x, and one of our equations was just x minus y equals 5. So in this equation, this is a little tricky because we're going to have a negative and another negative. So be careful here. We'd have x minus a negative 2 equals 5. So simplify this. When you see minus and negative, simplify that to a positive. So this is the same as x plus 2 equals 5. Subtract 2 from both sides, and we get that x is equal to 3. So now we have both of our variables. All we have to do now is put them together for step 5 and say that our coordinate pair would be 3, negative 2. And then we plug that point back into both of our equations in order to check. All right, sometimes when you substitute an expression for a variable, sometimes you substitute an expression for a variable that has a coefficient, and we'll need to use the distributive property. I'll show you what I mean in an example. Also, make sure that when you solve one equation for a variable, you have to substitute that into the other equation, not the one you just solved, or you'll get something like 3 equals 3. All right, so in this one, should we solve the top for y, the top for x, the bottom for y, or the bottom for x? Pick the simplest. There's no number in front of the y. So solve the top one for y. And we can do that just by subtracting 6x from both sides. So we solve the top one for y. And we get y equals negative 6x plus 11. Or you could write this as 11 minus 6x. That's fine too. Now we have to take this, what y is equal to, and we have to put it in the other equation where we see a y. So we don't put it back into the top equation because it'll just be a circle then. So now we rewrite the second equation as 3x plus 2 parentheses negative 6x plus 11. Here's what I meant by the distributive property. There's a number in front of this variable, so you'll have to take and multiply everything by 2 here, the distributive property. So when we do the distributive property, we get 3x plus 2 times, let me just write what we had. We had 3x plus 2 times negative 6x plus 11. This was the equation on the page before. So we take 2 times negative 6x and then 2 times 11. And then we simplify. So when we simplify this, we multiply those things by 2, and we get 3x minus 12x plus 22 equals negative 5. Combine your like terms. 3x minus 12x is negative 9x. And then we subtract 22 from both sides. We get negative 9x equals negative 27. Divide both sides by negative 9. This is a good review of solving equations. And we get x equals 3. So finally, this one took a little while, but we finally have our value of our first variable, that's x equals 3. Now once you have that, remember you have to go back up here and you have to solve for y. So pick whichever equation you think looks better. I think the top one does. And you write that down, and then you replace the x with 3. So I have y plus 6 times 3, and you just keep solving this to find what y is equal to. So subtract 18 from both sides, and you get y equals negative 7. So now that you know what x is, you know what y is, you write this as a coordinate pair, and then you check. Now when you check, you don't have to show all of your work. You can kind of check in your head or off to the side. So on the first equation, I would have negative 7 plus 6 times 3, that'd be 18. Is that equal to 11? Negative 7 plus 18, yep, that checks. Then in the second equation, I have 3 times 3, that's 9, plus 2 times negative 7, that'd be negative 14. Is 9 plus negative 14 equal to negative 5? Yep, that checks. So now you know that this is the correct solution to your system of equations. This is just going to be doing that step by step, what we just did. Okay, so on number 9 on your worksheet, we're going to have a problem like this. Now again, your first step is to solve one of the equations for a variable, and you want to pick the easiest one. So if you have a variable that has no number in front of it, like again the y here, that's probably the one you want to solve for y. You could solve any of these for x or any of them for y. It's just that you might have fractions and so on. But the top one, solving for y, is not going to be too bad. All we'll need to do is add 2x to both sides, and we'll have y equals 2x plus 8. Now that we know what y is equal to, 2x plus 8, we can use the second equation, write the second equation, except instead of y, you're going to put 2x plus 8. Now we're going to have to use the distributive property on this one because we have 2 times 2x plus 8. So when we use the distributive property, we will get 3x plus 2 times 2x is 4x, plus 2 times 8 is 16, equals 9. And then your next step will be to simplify by adding your like terms. Again, this is all solving equations, which we learned last semester, and you've been practicing for a long time. Then we would solve this for x and keep going. I'll go to the next page to have a little more room here. So subtract 16 from both sides, and we get 7x equals -7, and then divide by 7 to get x equals -1. Now once you know what x is, don't forget that we still have to find y. So you can pick either one of these equations to substitute the x value back in and solve for y. I'm going to pick the top one. I'll do it over here. So we'd have -2 times x, but x is -1, plus y equals 8. -2 times -1 is a +2. So y is equal to 6. Then step 5 is to write this as an ordered pair. So -1, 6. And step 6 is to check. And I usually check just by going back to the equations and solving them real quick. So is -2 times -1, that would be 2. Is 2 plus 6 equal to 8? Yep, that checks. And then in the bottom one, I'd have 3 times -1 plus 2 times 6. So that's -3 plus 12. Is -3 plus 12 equal to 9? Yep, so that one checks as well. So you solve for the first variable, then you plug it back in, and you find the value of the second variable, write it as an ordered pair, and check your work. You can also do word problems with solving a system of equations. In this example, Jenna is deciding between two cell phone plans. The first plan has a $50 sign-up fee and costs $20 a month. The second plan has a $30 sign-up fee and costs $25 per month. After how many months will the total cost be the same? That question, when they'll be the same, is asking what is the solution to the system. So the first thing to do then is to write an equation for each of your plans. We're going to use total paid is equal to the sign-up fee plus the payment amount for each month. So our first option, we have that the total T is equal to $50 plus $20 per month, so that's 20M. Our second option is that the total cost is equal to $30 plus $25 per month. Both equations are already solved for T, so we don't have to do step 1. Step 2 then is to say that if T is equal to 50 plus 20M, then we can replace that T in the second equation. So now we have 50 plus 20M equals 30 plus 25M, and we solve this equation for M. So to solve for M, we need to get our M's together, so subtract 20M from both sides, and then we would have 50 equals 30 plus 5M, subtract 30 from both sides to get 20 equals 5M, so M is equal to 4. Once you know what M is, just plug that back into either one of your original equations to find what the total cost is. And we find that our total cost is equal to 130. Now remember, our M was months, and our total cost was 130, so that means that at 4 months, it is $130 for either option, which is a pretty good value for cell plans. All right, so there's a similar question on your worksheet like that, so you'll have some practice writing your equations and solving, and you can find what the cost would be or when the cost would be the same for both of those companies. If you have any questions, please let me know, and I will talk to you soon. Thank you very much.